Saturn V Quarterly Film Report number 13 covers progress during the period December 1st, 1965 through February 28, 1966. Development, manufacturing, and testing of S-1C stages by the Boeing Company and the Marshall Center continued throughout the quarter. The final firing of the S-1C static test stage was conducted at Marshall on December 16th. This brought the total number of tests to 15 for a total firing time of nearly 15 minutes. Mission successfully accomplished, the stage was removed from the static test stand on January 20th and transferred to the manufacturing area for refurbishment. It will be shipped to Marshall's Mississippi test facility in November for the initial firing in MTF's new S-1C stand. The first S-1C flight stage completed its post-manufacturing checkout and was moved to Marshall's test lab on January 24th, the same date on which the second flight stage was transferred from Manufacturing Engineering Lab to Quality Lab to begin its checkout. The first flight stage was then installed in the static test stand, replacing the static test stage. Following LOX load tests and final preparation for firing, the stage underwent the first of two acceptance static firing tests on February 17th. Its 5 F-1 engines producing 7.5 million pounds of thrust, the booster's initial firing, 40 seconds in duration, was completely successful. On February 25th, the second firing was conducted. Scheduled for 125 seconds, it was cut off at 83 seconds when a failure of engine number 1 chamber pressure transducers occurred. However, review of post-firing data indicated no serious irregularity and no further static tests are necessary. After refurbishment, the stage will be shipped to KSC in July. Post-manufacturing checkout of the second flight stage is due to be finished early next quarter, following which the stage will be moved to the static stand for firing. At Marshall's Michoud assembly facility in New Orleans, post-manufacturing checkout of the facility's checkout stage ended in early January. The stage was weighed, prepared for shipment, and transported to the barge Poseidon, which left on January 15th for KSC. The booster will be used there in checkout of Launch Complex 39. The first F-1 engine for the third flight stage was installed on January 21st. All 5 engines had been mounted by the end of February. The booster will be moved to the stage test building for post-manufacturing checkout in March. The fourth flight stage is nearing the final phase of assembly at Michoud. Fabrication and assembly were in progress on the stage's thrust structure, fuel tank, and intertank. Work commenced in December on the 6th flight stage with installation of Z-stiffeners for the center engine support. Assembly of Y-rings for the stage got underway in January. The first cluster firing of the S-2 battleship stage using flight configuration J-2 engines was successfully accomplished on December 29th at North American Aviation's Santa Susana, California Field Laboratory. The initial static test was for 19 seconds as scheduled. On January 12th, the first full-duration firing was held. During the 354-second test, the engine gimbaling system was successfully operated. Another objective was to check out the stage's liquid oxygen cutoff system, which terminates propellant flow when the LOX reaches a preset level. A second full-duration firing was held February 22nd. The facility's checkout stage was completed on February 18th by the S-2 prime contractor, North American Space and Information Systems Division, at its Seal Beach, California facility. Following preparations for shipping, the stage was loaded aboard the Point Barrow, an ocean-going vessel, en route for the Kennedy Space Center. Final assembly of the first flight stage was underway during the quarter in the vertical assembly building at Seal Beach. In January, the stage was transferred to the hydrostatic test station for pneumostatic testing. Upon completion, the stage was returned to the assembly area for systems installation and installation closeout to be followed by mounting of engines and completion of mechanical and electrical installations scheduled next quarter. Fabrication of structural components and assembly of major structural subassemblies for the second, third, and fourth flight stages continued. Parts such as these S2 skirts are manufactured at S&ID's Tulsa, Oklahoma plant. Double-seal cryogenic sidewall insulation for S2 liquid hydrogen tanks is also produced at the Tulsa facility. Items of ground support equipment manufactured at Tulsa include these tank servicing mechanisms and tank pressurization control units. Other GSE is produced at S&ID's Compton, California facility. Typical of work done there is this assembly of GSE drawers and consoles, some of which are already being installed at the Marshall Center's Mississippi test facility. Qualification testing of various S2 components, such as this umbilical disconnect system at the Downey facility, was in progress throughout the quarter. Disconnection occurs as Saturn V liftoff is simulated. Factory checkout of the first S4B flight stage was concluded in January by the Douglas Aircraft Company at its Space Systems Center at Huntington Beach, California. The stage will be shipped to Douglas's Sacramento test facility early next quarter for acceptance firing tests. Structural work, including installation of skirt components, continued on the second flight stage early this quarter. Stage joining operations were completed in mid-February, and factory checkout is now underway. During hydrostatic testing of the third flight stage on February 24th, the LOX tank failed, although at a pressure far above that normally expected during flight. Preliminary assessment indicated the problem to be in the area of an excessive weld repair. Program impact, if any, is being investigated. The S4B stage simulator was delivered to SACTO in December and installed in the newly completed vehicle checkout lab for continuity tests in conjunction with automatic GSE. Completion of tests is expected early next quarter. Structural testing of the S4B common bulkhead test specimen under cryogenic conditions began at SACTO in December, and 7 tests were successfully conducted. Although the specimen finally failed during the test on January 13th, data from the prior tests indicated no problem with flight stages. At SACTO's Gamma Complex, static testing of a prototype model of the Saturn V S4B auxiliary propulsion system was conducted during the quarter. The widespread S4B qualification testing program is proceeding on schedule with items such as vibration tests of retro rockets at the Thiokol Chemical Corporation's Wasatch Division in Utah, vibration, thermal shock, and functional testing of the S4B's main fuel feed duct at Douglas's Santa Monica facility, and testing of the S4B oxidizer duct assembly at Wiley Labs in El Segundo, California. Assembly and delivery of the F1 engines for the third S1C flight stage, the initial manned configuration stage, were completed by Rocketdyne during the quarter. One of the major components is this Mark 10 turbo pump, shown here in early build-up stage, with the main shaft in an assembly jig at Rocketdyne's Canoga Park, California plant. In a later assembly stage, the fuel volutes are in place. This is how the pump looks prior to buildup of the turbine section and LOX pump. In its final stage, the pump's secondary LOX seal, LOX volute, and turbine manifold are all installed. After a final inspection, the pump is taken to the Santa Susana site for testing. The large flame at the top of the stand is the afterburner. This instrumentation film shows an F1 engine turbopump during a hot fire testing at Santa Susana. In the developmental area, Rocketdyne has been contracted by NASA to develop an instrumentation system for measuring radiative heat from the exhaust plume of an F1 engine and to perform an analysis of exhaust plume radiation processes. The study will assess the role of carbon as a thermal radiator and the geometry, location, and progress of afterburning phenomena. The J2 engine qualification test series was completed by Rocketdyne on December 22nd. The series, conducted at Santa Susana, served to man-rate the J2. The engine was fired 30 times for an accumulated duration of 3,750 seconds. In early January, J2 qualification service life tests were conducted with 7 successive full-duration 500-second firings. Also at Santa Susana, a study was performed to provide data on the movement of LOX during a firing. In sequence, the film shows introduction of helium to subcool the propellant, pressurization of the run tank with gaseous nitrogen, and depletion of the tank during firing. A series of vibration tests was conducted at Rocketdyne's Canoga Park plant, subjecting the J2 to simulated loads of the S1C stage boost phase. The tests simulated those flight loads expected at booster ignition, liftoff, maximum aerodynamic load, Mach 1, aerodynamic gusts, and steady-state flight. No discrepancies were noted. Following an electromechanical checkout, the vibration test engine was installed in a test stand and fired for a full duration. A new facility, an electrical assembly clean room production line, has been placed in operation at Rocketdyne's Canoga Park plant. The facility is used in the buildup of electrical control assemblies for the J2 engine system. A total of 7 J2 engines was delivered by Rocketdyne this quarter to the Saturn V stage users, including 3 for the third S2 flight stage, 2 S2 spares, 1 S4B spare, and 1 for testing at the Air Force's Arnold Engineering Development Center in Tullahoma, Tennessee. A Douglas S4B battleship stage, which will be used for tankage in the tests, was delivered to Tullahoma on January 22nd. Following installation in the test cell and mounting of the J2 engine next quarter, firing tests will begin in July for verification of start, restart, and engine performance at simulated high-altitude conditions. The Flight Systems Instrument Unit was completed on December 6th at the Marshall Center and was moved into the Quality and Reliability Assurance Lab for checkout. In mid-February, final checkout operations were completed on the unit, together with the 3 IBM checkout trailers housing equipment for telemetry, radio frequency, and digital data acquisition systems checkout. The IU and checkout equipment are being moved to Douglas Aircraft's Huntington Beach facility, where functional tests will begin next quarter in an environmental chamber simulating orbital thermal vacuum conditions. The vibration test IU was emplaced in a fixture for mechanical vibration testing at Wiley Labs' Huntsville facility in December, following successful completion of acoustic tests last quarter. The mechanical program was successfully concluded by Wiley on January 20th. After Marshall had updated the facility's checkout IU to the flight configuration, it was shipped to KSC on February 28th for use in checking out Launch Complex 39. Structural testing of the second structural test IU began December 30th at Marshall. After a series of successful tests, the unit crumpled on February 2nd at 140% of maximum aerodynamic load, the exact safety factor for man rating. 2 more tests had been planned. The IU has now been broken down into sections for post-test examination, and an evaluation of all test data is underway to determine if additional testing using a new unit will be required. Installation of components in the first and second flight instrument units got underway this quarter at IBM Huntsville. Completion of installation and start of checkout of the first flight IU are scheduled for mid-May. Build-up of IBM's checkout capability continued during the report period. In the area of component test equipment, this new turn-tilt test stand was added in January for use in checking out the ST-124M inertial platform subsystem before installation in the IU. Also, IBM's new aerospace system test and evaluation console, known as Aztec, was being checked out this quarter and will be operational in April. The previous Aztec unit has been incorporated into IBM's simulation laboratory. For use in checkout of the fully assembled IU, the Saturn V Central Control Room, now under construction by IBM, will be operational in May. IBM's Instrumentation and Communication Acceptance Complex, which ties into the Central Control Room, was completed in January. It has the capability of testing various telemetry components. At Marshall's Saturn V GSE test facility, umbilical disconnect testing began this quarter on the swing arms which will be used on the mobile launcher at KSC's Launch Complex 39. Airplane engines generated winds up to 75 miles per hour to simulate wind loads which might buffet a Saturn V vehicle on its pad in Florida. The swing arms, which provide for personnel access, propellant loading, and electrical and pneumatic connections, will be shipped to KSC upon completion of testing. Build-up of Marshall's Saturn V Systems Development Facility is continuing with installation of the F1 engine this quarter. The facility is a breadboard or simulation of Launch Vehicle Automatic Checkout GSE at Launch Complex 39, plus components simulating a completely assembled Saturn V vehicle. Purpose of the facility is to verify compatibility between the Saturn V and Launch Vehicle GSE, and also to develop and verify checkout tapes which will be used for actual launchings. The breadboard instrument unit was also delivered to the breadboard facility during the report period. Prior to the Saturn V program and the Launch Vehicle GSE concept, Stage Peculiar GSE, that is designed for individual stages only, had to be used at the Cape for checkout of the fully assembled vehicle. Installation of electrical support equipment at the Saturn V breadboard facility continued throughout the quarter. At Marshall's Saturn V Dynamic Test Stand, installation of the Saturn V Dynamic Test Vehicle's first stage was accomplished on January 14th. Testing of the stage to determine vibration and bending characteristics during flight will begin this summer. Later, the two upper stages, IU and dummy Apollo spacecraft, will be added for full-scale testing. Meanwhile, prior to start of dynamic testing, checkout is underway of the hydraulic support system on which the booster rests in the stand. The system was built and installed by the Martin Company of Baltimore. At Marshall's Mississippi Test Facility, preparations are continuing to ready the first S2 static test stand, designated A2, for the initial S2 firing scheduled next quarter. Modifications of the S2 all-systems stage, which was installed in the stand last quarter, are also continuing. Construction of the second S2 stand, designated A1, is progressing steadily, and the stand is 58% complete. At the dual-position S1C static test stand, concrete work and erection of steel continued throughout the report period. The test control centers for both areas have been finished except for installation of equipment. The data acquisition facility is now operational. In summary, the period December 1, 1965 through February 28, 1966 witnessed the achievement of significant program milestones, including the successful acceptance static firing of the first S1C flight stage, shipment of the S1C and S2 facilities checkout stages to KSC, the first cluster firing of the S2 battleship stage using flight configuration J2 engines, factory checkout of the first S4B flight stage, completion of the J2 engine qualification test series, successful instrument unit vibration tests, testing of GSE items such as the mobile launcher swing arms, and preparation for the initial S2 static firing at MTF.